hopefully. There we go. Okay, so today we're getting into 4.7, and 4.7 involves the law of sines and the law of cosines, and a couple other applications of the law of sines and cosines. But what we're really going to focus on for today is the law of sines, and not the law of cosines yet. That will be tomorrow. So, law of sines, here we go. Go ahead and grab whatever it is you're using to take notes, and we'll get started. So 4.7, this is part 1. Law of sines. Okay, so law of sines is going to be dealing with triangles, first off. And so we're going to be using trig functions, but we're not going to necessarily need right triangles now when we're using trig functions. So before, we've really only applied trigonometric values and functions to right triangles, and we've thought about them in terms of the unit circle and things like that. Now we're going to see how we can use them for any triangle. So here's what the law of sines states. If you've got a triangle, A, B, C. So these are our angles A, B, and C. The sides across from those angles will be denoted as the lowercase letters that go with the uppercase letter of that angle. So angle A is across from the side that's denoted by lowercase a. Angle B is across from lowercase b. Angle C is across from the side lowercase c. So the law of sines says that the sine of angle A divided by the side length A is equal to the sine of angle B divided by the side length B, which is equal to the sine of angle C divided by the side length C. So this can help us find pretty much every other measure of something in a triangle. So we can find, if we know angle A and the side length A, and maybe we also know the side length B, we can use it to find the missing angle B. And then we can also then use that to find C and angle C. So we can use law of sines, or the way we're going to be using it is to solve triangles. And so there's a few different situations where using law of sines is helpful. And so we'll talk a little bit about how we determine if we can use law of sines and and a couple of the different scenarios we run into with law of sines. But the basic requirement to use law of sines is that you need a matching side angle pair. So for example, we need angle A and side length A, or angle B and side length B, or angle C and side length C. You need one of those pairs where it's the angle and the side that are across from each other in order to use the law of sines. Okay. So if we're thinking like, if you remember all the way back to geometry, and you had those triangle congruence theorems, like angle, angle, side, or angle, side, angle, stuff like that. And then you had like side, angle, side, and all that good stuff. The cases where you can use law of sines are going to be the angle, angle, side case, the angle, side, angle case, or the side, side, angle case. This one, however, is going to be kind of a special circumstance case that we'll talk about later. So more on this one later. For now, we're going to focus, or for this moment anyway, we're going to focus on these two and the main idea that you need a matching side angle pair in order to use the law of sines. Okay. And so the easiest way to learn how to use the law of sines that I've found is to do examples involving using the law of sines. So that's what we're going to do. Okay. So the first example. We do, I'm going to give us a picture. Sometimes you'll be given a picture. Sometimes you'll be given some angle names and measures and side lengths and stuff like that. And that's where you're going to kind of want to draw your own picture. So if you're not given a picture, draw a picture. If you are given a picture, though, this is what it's going to, one of the cases, what it could look like. So we'll call this A, B, C. And notice your triangles don't all have to be named ABC. A lot of them will be named, will be triangle ABC, just kind of out of convenience and how it nicely matches up with the law of sines. But I mean, you can do this for any triangle. It doesn't have to be named ABC. And so sometimes you won't see it as ABC. But anyway, 103 degrees, 35 degrees, side length 20. And what we typically want to do, I guess it depends. Sometimes, like if it's an IXL section, they might be asking you for just one side length or something like that. But generally speaking, you'll want to know how to find all of the missing pieces. So you'd want to find, in this case, side length A, side length C, and the measure of angle C, since those are all the things that are missing here. Okay, so first thing we need to notice, we can use the law of sines because we do have one matching angle side pair where the angle and the side are across from each other. So we're good to go there. The first thing I would set up is sine of 103 over 20. We're going to be using that ratio. And we need to find A and C and angle C. So let's start with finding side length A. We know that sine of B over side B is equal to sine of A over lowercase a. So all we have to do there is then we know what angle A is. So I'm going to put 35 in there. We get sine of 103 over 20 equals sine 35 over A. Then we can cross multiply here. We get A sine of 103 equals 20 sine 35. Divide by sine of 103 on both sides. And we get A equals, this is something that we can type into a calculator. So the first thing you want to do on problems like this is make sure your calculator is in degree mode. I know we've been working in radian mode quite a bit lately. For pretty much all of these law of sines and law of cosines problems, though, you're going to be given angles in degrees. So take a moment with your calculator. If it's one of these, make sure you hit mode. Make sure your calculator is in degree mode. You can see it up here as well. And then if you're using Desmos, make sure you click the wrench in the top right corner and click on degree. Otherwise, it will be in radian mode and you will get answers that don't line up with everyone else's and don't exactly work very well. Okay, so we want to type this into the calculator. We want to type 20 sine 35 divided by sine 103. And we should get 11.773. So that's going to be part of our answer. That's side length A. Okay, so looking at our process so far, any questions as to how we found side length A? Any numbers we're not sure where they came from, or process or steps that we're not sure about? Okay. Then, finding side length C and angle C comes next. Finding angle C, you can use from, or you can do using knowledge you learned back in geometry. What do the angles on a triangle add up to? 180. And so we can take advantage of that here as well. We know two angles. So for finding angle C, we can just go 180 minus 103 minus 35. And that should give us 42. So angle C will be 42 degrees. So that's another part of our answer. So then we can find side length C the exact same way that we found side length A. We can go set up a new ratio over here, sine of 103 over 20 equals sine of 42 over C. Then we can do the whole cross multiplying thing. We get C sine of 103 equals 20 sine 42. Divide by sine of 103 on both sides. Toss that into a calculator. So we would go then 20 sine 35 divided by or not 35, sorry, 42 this time. Sine 103. And we get 13.735 approximately. And there's the three things that we needed. Angle C, side length A, and side length C. Okay. So that's one kind of problem that we might see, dealing with law of sines. Let's do another one. This time, I'm going to tell us some information, and we're going to need to draw the picture based off of that. So for this triangle, measure of angle A is 58 degrees. Measure of angle B is 72 degrees. And side length C is 446. And we need to find measure of angle C, side length A, and side length B. Okay, so the first thing we want to do is draw a picture. It doesn't have to be an accurate picture as far as like making sure you have all the like side lengths correct and everything. It's just going to be a generic picture that helps us out with figuring out which things are across from each other and which things will go well to or which things we want to use together with law of sines. But if you don't have to draw the picture, if you can kind of picture it yourself, or if you just want to use the formula and go about things that way. But anyways, starting off here, we've got angle A is 58 degrees, angle B is 72 degrees, C is 446. We are looking for B, A, and then angle C. Okay. So on this one, it doesn't look like we have a case of the law of sines because we don't have a matching pair that are across from each other. Or do we? What's the missing angle going to be? Go ahead and figure that out real quick. When you think you've got it, type it in the chat. What's our missing angle going to be? Yes, it's going to be 50. So, because we could just go 180 minus 72 minus 58, that gives us 50. And now, magically, we have an angle side pair that are across from each other. So beware that this is a case that could happen. This is kind of the angle side angle case of things where you want to use law of sines. The one that we did in the first example was an angle side case. But anyway, so this is the angle side angle case where you find the missing angle and then that's across from the side that you have. So the thing that we're going to set up, sine of 50 over 446 is equal to, we're going to set up 2 here. We're going to have sine of 58 over A. And then we're going to set up the same thing over here. Sine of 50 over 446 is going to be equal to sine of B over, or sorry, sine of 72, which is B, over side length B. Okay, so now that we've set them up, go ahead and solve both of those. When you think you've got side length A and side length B, type "got it" in the chat. All right, Carson's got it. Paige has it, Jasmine has it, nice. On the first one, if you're on the right track, this is what you did. You cross multiplied and then divided by sine of 50. On the other one, same thing, cross multiplying and then dividing by sine 50. And then typing it into the calculator. So we should get For A, if you got 493.743, you are correct. And for B, if you got 553.716, you're correct. One way that you can kind of check yourself and make sure that you're on the right track, if you remember that property from geometry that the bigger side is across from the bigger angle and the smallest side is across from the smallest angle, notice how C is the smallest angle, and 446 is the smallest out of the three sides. Angle A is 58, it's the medium-sized angle, and side length A is in between the other two sides that we found. And then the largest angle is B, and the largest side is also side B. So that's one way that you can kind of check and make sure you're on the right track. But yeah, anyway, so there's another one. Any questions off of that problem? Any numbers we're not sure where they came from or anything like that? Okay. Then, sorry, my dog is whining out there. Let's see. I'm gonna have you guys try one on your own, and then we will get the assignment from there because this is all we need to really cover today. We will talk about the other case that I mentioned, the SSA case, but we're gonna talk more on that one later, not today. So I think this is enough to absorb for now. So the U try. This time, let's see, we're gonna have for triangle ABC, angle A is gonna be 19 degrees. Measure of angle B is gonna be 63 degrees. And our side length A is 5. And we want to find measure of angle C, side length B, and side length C. So take a couple minutes, try that one out. When you think you've got it, type got it in the chat, and we will talk about it. And then we'll get on to homework. You certainly don't have to draw the picture, but I recommend it. If that's the picture you drew, you're on the right track. And if you got 98 degrees for angle C, that will help. And then the two equations that you want to set up should look like sine of 19 over 5 equals sine of 63 over B. And then sine of 19 over 5 equals sine of 98 over C. So if you set those equations up, then you're looking good. When you think you've got it, type what you got for B and C in the chat. All right, Teresa's got it. Jasmine's got it. Nice job. All right, so for both of these, we want to make sure that we cross multiply. And then we want to divide. So into the calculator for B, we would stick 5 sine of 63 over sine of 19. And we would get that B is indeed 13.8 or 684. So there's one of our answers. Same thing for C. We'd get C sine of 19 equals 5 sine of 98. And then we would divide by sine of 19 on both sides to get C is 15.208. Okay. So that's the law of sines in a nutshell. The other case that we're going to talk about later will be, it's considered the ambiguous case of the law of sines. And it's a case where you get, where there's actually, sometimes there's multiple triangle possibilities. You could end up with no solution, 2 solutions, or 1 solution. But again, we will talk about those another time. Tomorrow we'll get on with the law of cosines, and then I think on Friday we'll round things out with the ambiguous case, and we'll also talk about how you can find area using law of sines and cosines. So that's what you have to look forward to. But for now, on a scale of 1 to 5, 1 being I'm completely lost, 5 being this is super easy, I could teach this to somebody. What are we feeling? Okay. Looks like most of us are feeling fairly confident. Here's what we'll do. I will post the homework. It's only one IXL section today. So we're taking things uh, fairly easy on this. One IXL section. If you would like to stick around and do more examples with me, you can. Or if you want to stick around and like do an example of the IXL with me, you can. Otherwise, I will let you guys go and work on your own. So here we go. There's the assignment. M14 to a SMART score of 80. If you would like to work on your own, you're free to go. If you would like to do more examples with me, then you can stick around and do more examples with me.